So, with proofs, what we have is we are going to be given some information, and then we have, using that information and using the pictures that are given, we have to prove that the two triangles are congruent by one of the 5 postulates. So, first proofs we're looking at is side, 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 and side angle side. With a proof, we're doing 2 column proofs. You're given statements and reasons. So the statements is always something that you know, and then you have to tell why you know that. So, with a side, side, side proof, in order to prove that 2 triangles are congruent using side, 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 we have to know that the 3 sides are congruent. So here, it says if AB is congruent to what side? DE. And BC is congruent to EF. And AC is congruent to DF. Then we can say that triangle ABC is congruent to triangle DEF by side, side, side. So if I know those 3 things, then I can prove by side, side, side.
That's confusing.
Okay. So in this first proof, we are given 3 different things, okay? So I'm given PQ is congruent to ST. So my reason for knowing that is that it's given. We're given QR is congruent to TR. Reason for that is given. And then R is the midpoint of PS. I know that because it's given. So with these, you're always given a picture. And I've already marked this one, but you're always going to have to mark your pictures, okay? So I went ahead and marked PQ congruent to ST, marked QR congruent to TR. And then I know that R is the midpoint of this whole line. If R is the midpoint, mid means it's in the middle, right? So that means it's splitting it in half. So that means these 2 parts are congruent because that's the midpoint. So I could mark those 2 parts congruent because of that. So if I'm ever given a midpoint right here, one of my reasons is always going to be definition of midpoint. And over there on the board in the blue, I've written the reasons that you can possibly have on a proof. So with sides, it's either going to be reflexive property or definition of midpoint. So if I have right here that PR is congruent to SR, I'm saying this part is congruent to this part. How would I know that from what it told me?
They share a midpoint.
Because of the midpoint. So we know that because of the definition of a midpoint. So now, if I look in this proof, I've proven a side is congruent to a side's congruent to a side, and another side is congruent to a side. So I've proved 3 sides are congruent. And I can look at that picture and I can see I have 3 sides marked, right? So how would I know those 2 triangles are congruent? Which postulate? How would I know if those 2 triangles are congruent? Which one of the 5? Side, side, side. So my last reason will be SSS. Okay. Number 2. It tells me JL is congruent to NM. So I went ahead and marked JL congruent to M or NM. I went ahead and marked those for you. Marking your pictures is important. They're not always going to be marked for you. So went ahead and marked that. I already have it down here in my statements, and I know it's true because it's given. Okay. My next thing is K is the midpoint of JN and LM. So K is the midpoint twice here. So I'm going to have definition of midpoint how many times?
Twice.
Twice. Okay. So, since K is the midpoint of JN, it's the midpoint of that line right there, I know that JK is congruent to NK. JK is congruent to NK by what reason? Definition of midpoint. Then it tells me again K is the midpoint of LM. So LM right here has a midpoint at K. So those two parts of that line are split in half. I already marked them with the 3 tick marks. So how do I know LK is congruent to MK? Definition of midpoint. And then what I'm trying to prove is triangle JKL is congruent to triangle NKM. How would I know those two triangles are congruent? Side, side, side. I can just look at the picture, see what I've marked. I've got 3 sides, so it's side, side, side. Or you can look in here, you see you have a side congruent, side congruent, side congruent. So side, side, side. Okay. Page 13, number 3. So it tells me AC is congruent to AD. I'm going to go mark that. AC congruent to AD. Marks that. So that would be my first statement. How do I know that's true? Because they gave it to me, right? So I can write, I know that's true because it's given. We just proved a set of sides were congruent. So then it says CB is congruent to DB. So I'm going to mark those. CB congruent to DB. And how did I know that was true? Because it's part of my given. Now, if I wanted to do something else, if I was just looking at this and I wanted to see what the postulate was here, what could I mark?
The line, the AB line.
The AB line. Why can I mark that? Because it's shared. It's called reflexive. So from that, I know that side AB is congruent to side AB, right? Because they're the same. So for my third one, I'm going to put AB is congruent to AB. And the reason I know that is because they are reflexive. So the reason there would be reflexive property. So now my proof, in my statements, I have 3 sides congruent. In my picture, I have 3 sides congruent. So how are those 2 triangles congruent? Side, side, side. Okay, so that's side, side, side proofs. Now we're going to look at side, angle, side proofs. So in order for this to be true, we have to have 2 sides and their included angle. So if AB is congruent to what side on the second triangle? DE. And angle B is congruent to angle E. And side BC is congruent to side EF. Then those 2 triangles, triangle ABC is congruent to triangle DEF by side angle side. Okay, so in this proof, it's given to me that JM is congruent to LN. I went ahead and marked that for you. What's my reason for knowing that? It's given. Then I have angle JMN is congruent to angle LNM. I already marked those for you. And how would I know that? What's my reason for knowing that? It's given to me. So, now I can mark something else. What can I mark? Two sides are touching. I can mark them as congruent, right? So side MN is touching side NM because those are reflexive sides. So what's my reason for knowing MN is congruent to NM? Reflexive property. Now, how can I prove that triangle JMN is congruent to triangle LNM?
Side angle side.
Side angle side. Okay, number 5 has something new here. It's got a bisect in there, so we're going to have something different this time, or something new. So first thing it tells me, I'm given AB is congruent to CB. So the first thing I'm going to do is I'm going to go mark those two sides congruent. AB congruent to CB. And I know that's true because it is given to me. Then it tells me BD bisects ABC. So here's angle ABC, and BD is bisecting it. So it kind of creates a little arrow when you highlight what it is. So if an angle is being bisected, that means it's being split into two equal parts, right? So two of the exact same parts. So that means these two angles are congruent. Because those angles were bisected. So I know that happened because it was given to me. And then my third statement says angle ABD is congruent to angle CBD. So angle ABD congruent to CBD. How would I know those two angles are congruent? How was I able to mark those? Because I was given what? A bisect, right? So anytime you have bisects, you're going to have definition of angle bisector. So I know those two angles are congruent because of the definition of an angle bisector. Okay, the next statement I have is BD is congruent to BD. So that means BD and BD are the same. How would I know those two sides are congruent?
It's the same one.
Because it's the same line. What property is that?
Reflexive.
Reflexive property. Okay, so if I look at my statements, I said two sides were congruent, two angles were congruent, two sides were congruent. So I have a side, an angle, and a side. Looking at the proof, I have a side, an angle, and a side. So how would I know these two are congruent? By what postulate? Side, angle, side. Okay, number 6, it says B is the midpoint of WZ and XY. So how many times am I going to have definition of midpoint?
Twice.
Yes, I'm going to have it twice. So I already know 2 of my reasons. So if V is the midpoint of, so I know this is the midpoint, but it's the midpoint of WZ. I know it's the midpoint of this line. So what does that mean about WV and VZ? They are congruent. So if I'm looking at statement 2, it says WV is congruent to ZV. I know that because of what? Midpoint. Definition of midpoint. How do I know that first statement was true? Because it's given. So I've already proven a side's congruent. Now the next thing it says is angle WVX is congruent to angle ZVY. So both of those are at vertex V. So if I mark them, it's these 2 angles. What kind of angle pair are those?
Vertical.
They're vertical. So I know they're congruent because they are vertical angles. That's a new reason. And then going back to what I knew about midpoint, V was the midpoint of XY. So that's XV is congruent to YV. How would I know that? Definition of midpoint. So I use definition of midpoint twice, like I said I would. So I've proven 2 sides are congruent and an angle is congruent. So how can I prove those 2 triangles are congruent?
By same
Side, angle, side. Okay, so far the reasons we've seen are reflexive property, definition of midpoint, vertical angles, angle bisector. Now in the next one, when you're given parallel lines, you could possibly have one of these 3 things: alternate interior, alternate exterior, or corresponding. So, looking at this next one, it tells me HI is congruent to JG, so I'm going to mark that, HI congruent to JG. And I know that because it's given. Then it says HI is parallel to GJ. So I'm going to draw little arrows on those to show that they're parallel. And I know that reason is given because it was given to me. So now, anytime you have a set of parallel lines, you could possibly have one of those 3 things: alternate interior angles, alternate exterior angles, or you could have corresponding angles. So since we have parallel lines here, we're going to have one of those 3, or at least one of the 3. going back to my statements, number 3 says angle GJH. So GJH. That angle right there. So I know that angle is congruent to angle IHJ. IHJ, so this one right here. So I'm going to mark those as congruent. So how would I know those two angles are congruent? They're on parallel lines, right? They're on this set of parallel lines.
Because they're interior.
Alternate interior angles. So those two angles are alternate interior angles. You just put AI angles. So I just proved those two angles are congruent. And then the last statement it has for me is HJ is congruent to JH. How would I know those two sides, HJ and JH, are congruent? Reflexive property. So now, how would I know those two triangles are congruent? Side angle side. Okay, page 15. Now we're looking at angle, and angle, side proofs. So, in order to do that, you have to have two angles and then include a side for angle, side, angle. So, if angle A is congruent to angle D, side AB is congruent to side DE, and angle B is congruent to angle E, then those two triangles, triangle ABC is congruent to triangle DEF by angle, side, angle. Okay. So, number 1 on page 15 tells me that I'm given SQ bisects angle RQT and angle RST. So how many times do I have a bisector? Twice. Because it bisects two angles, so that means I'm going to have definition of angle bisector 2 times. Okay, so it says it's bisecting RQT and RST. And that middle line is doing it. So I know that's true because it's given. Now my second statement says angle RQS, so this angle right here, is congruent to angle TQS, this one right here. How would I know those two angles are congruent? Definition of what?
Right.
Angle bisector. So definition of angle bisector is always with angles. Definition of midpoint is always with sides. So now I've proven two angles are congruent. Then my next statement says angle RSQ is congruent to angle TSQ. Right now, I'm really just using my statements to mark my picture. I'm not even really having to think about what the Given, yes, because I'm already given these statements, then I can use them to mark my picture. But how would I know those two angles are congruent? Definition of angle bisector. So now I've got two angles. Now I need to prove a side. So it says QS is congruent to QS. How would I know that's true? Which property? Reflexive.
Yeah.
I know those are congruent because of reflexive property. So now I've proven two angles and a side, so it's either angle, angle, side, or angle, side, angle. Which one would it be for this proof? Angle, side, angle. So it's not always going to be in the right order in the statements. That's why you have to write it on the picture. That's why you mark your pictures, so you can say it's angle, side, angle by looking at it.
Yes.
So now that next one, all it gives you is that you have two sets of parallel lines. If I have two sets of parallel lines, what can I possibly have? I can have alternate interior, alternate exterior, or corresponding angles. So, it already gives me all my statements. So I can really just go through and mark the picture given my statements. I'm going to mark those parallel lines. JK parallel to LM. JL parallel to KM. So I marked what I was given. So now, first statement, other than the given one, JKL is congruent to angle MKL. So JKL, this angle, is congruent to MLK. So I just marked it because that's what it told me. So how would I know those two angles are congruent?
Alternate interior.
Alternate interior angles. Okay. So now the next set of parallel lines, JL and KM, they also create that Z in there. So I'm going to look at my third statement. JLK is congruent to MKL. Notice they're inside the blue Z. So how would I know those two angles are congruent?
Alternate interior.
Alternate interior. So now I've proven two angles. Now I need a side. So it says KL is congruent to LK. How would I know that those sides are congruent?
Reflexive.
Reflexive property. So now how would I know those two triangles are congruent? So I have either angle side angle or angle angle side. Because I have two angles and a side.
Angle, side, angle.
Angle side angle. So I have an angle, then I have a side, then I have an angle. Angle side angle. These aren't too bad, right? Y'all are such happy people this morning.
I can barely see the floor.
We'll get in the next chair.
This is my shit.
Okay, then, that's okay.
Hey, you can sit right now. I'm like part blind right now. I don't know why, but I can. You can pause.
Okay, so on page 16, number 3, it says angle, we're given angle BAC. Angle BAC is congruent to angle DEC. So I know those two angles are congruent. Then it says C is the midpoint of AE. I know C is the midpoint of just that line. It only tells me it's the midpoint of just that line. So, I know that. So I'm going to go ahead and write what are my first two reasons here. Given, because those two things were given. And then I'm not given my other two statements. So I'm going to have to go off of what I know. So I know one of my reasons is going to be what, since I'm given this? Definition of midpoint, right? So I know that's going to be one of my reasons. I don't know why I'm not definition of reason. Lord knows. Okay, so I need to write my statement for what I got from definition of midpoint. So by the definition of midpoint, I know that those two lines are being split, or that line's being split in half at C, right? So what does that mean about AC and EC?
Congruent.
They're congruent. AC is congruent to EC. By definition of midpoint. We were able to mark that because of midpoint. And now I need something else. I can't mark another side because no sides are shared. But what kind of angles do I have right there in the middle of that bow tie? Vertical angles, right? So I know I have a pair of vertical angles, so I'm going to go ahead and name those vertical angles. So C is the middle of both of them, right?
ACB.
So it's going to be my middle letter in both of the three-letter angles. Can't just put angle C, it's congruent to angle C. So angle ACB
CB.
is congruent to angle, what?
ECB.
ECD, if you want to be technically perfect. B goes with D, and then CE. So I'm just putting how they line up. Wait, did I do that wrong? Yes. I did it backwards on my paper. He was right. Let me know. I wrote angle BCA is congruent to angle DCE. But y'all want an angle ACB is congruent to angle BCD. So, again, you can write it two different ways there as long as C's in the middle is fine. So I know those two angles are congruent because they are vertical angles. So now I have an angle, and I have a side, and I have an angle. It's either angle, angle, side, or angle, side, angle. Here I do have two angles with the included side, so it's angle, side, angle. Okay, anybody got any questions for me? Okay, so our fourth type of proof we can look at is angle, angle, side. Angle A is congruent to angle D, and angle B is congruent to angle E. And side BC is congruent to side EF. Then those two triangles, triangle ABC is congruent to triangle DEF by angle, angle, side. Okay, so in example 4, we're given YZ bisects angle WYX. So I know there I'm going to have a definition of angle bisector, right? So I know that's going to be one of my reasons. And then it tells me angle YWZ. YWZ is congruent to angle YXZ. And I know those first two statements are true because they are given to me. Okay, most of the time you're going to be given most of your statements, but sometimes you're not. So that's why we're having to practice with writing statements right here. So, based off of what we've got, I can mark my angle bisector stuff and then I can mark a side. It doesn't matter which one you put first, as long as you put them both in there at some point. But going off that bisector, if YZ bisects this angle, what do I know about both of these angles? They're congruent, right? So that means angle WYZ is congruent to what angle? XYZ. Because W goes with X, Y goes with Y, Z goes with Z. And I know it's that angle, XYZ. So I know those two angles are congruent. How do I know it? Definition of angle bisector. So now I have two angles. So I need a side. What side can I mark congruent? Middle. YZ. Can mark that middle side. So that means YZ is congruent to YZ. By what property? Reflexive. Okay, and this one doesn't even have the prove at the bottom, but what we're trying to prove always goes in this last blank. So triangle WYZ is congruent to triangle XYZ by what? Angle, angle, side, or angle, side, angle?
Angle,
Angle, angle, side. Right.
It's practicing. Oh my gosh.
Okay, so page 17, number 5. So it says angle ABC is congruent to angle CED. Went ahead and marked that for you. It says AB is parallel to CE. Went ahead and marked that. And then C is the midpoint of AD. So, based off of what I'm given, I know I'm going to have a definition of midpoint. And since I'm given parallel lines, I'm going to have one of my three, alternate interior, alternate exterior, or corresponding. So, I'm going to look at what I am given here. So, do you want to do the parallel lines first or the midpoint first?
Midpoint.
Okay, midpoint. So it says C is the midpoint of AD. So this bottom line. So if C is the midpoint of that line, then it's splitting it into two equal parts of the midpoint. So that means AC is congruent to what?
CD.
CD. So AC goes with CD. So I look back up at this. so that it can be technically more correct. If you mix that around and you do DC, I'm not gonna mark it wrong. Okay, it's fine.
That's the way it should be,
But this is the way it should be, it's AC.
ACDC, or CD.
AC, CD,
Oh, I know what.
AC. CD. Okay. So I know those are congruent because of definition of midpoint. So I went ahead and I've already used the midpoint part. So now I've got to focus on the parallel line part. So these are my two parallel lines. And then that bottom line is the only line that connects them other than the BC, which the BC wouldn't really help us, right? Because it could say alternate interior right here, but is that even in one of the triangles? No, so that doesn't help us. So alternate interior and alternate exterior are out. So what's my only other thing left for vertical line? Not vertical, parallel line. Corresponding. So these two angles are congruent because they are corresponding angles. They're in the same position on those parallel lines. So angle BAC is congruent to angle what? BCD, because those are corresponding angles. And then my proof always goes last. So triangle ABC congruent to triangle CED. And how would I know that? Two angles and a side. Is it angle, side, angle, or angle, angle, side? Angle, angle, side. Okay, number 6, PR bisects QRS. So if PR is bisecting QRS, what do I know about these two angles in QRS? They are congruent. So I know those two angles are congruent because of definition of angle bisector, right? So I'm going to go ahead and write those. Angle SRP is congruent to angle QRP. SRP, QRP. And I know those two angles are congruent by definition of angle bisector. I also need to mark what's given, and then I'm going to mark one other thing. Y'all go ahead and try that. Hello. Hey. Yeah. Yeah. Ash.
Coach. You sick?
Okay. So I used this bisect thing, but I still haven't marked what was given to me. So it says angle PSR is congruent to angle PQR. So the angle at S and the angle at Q. And I know that's because those were given. I just didn't do those first. I did my bisecting one first. So now I have two angles. That means I need a side. Which two sides are congruent? PR and PR. So I'm putting PR and PR because those are in the same position up here. They're corresponding. P goes with P, R goes with R. So PR is congruent to PR. And how do I know that? Reflexive property. Then I have triangle PSR is congruent to triangle PQR. I got that just from the proof part, just brought it straight down. How would I know those two triangles are congruent? Angle, side. Okay, I want y'all, when you finish with number 6, to go ahead and try number 7. All your statements are given. You just have to fill in the reasons. So there's parallel lines. So you're going to have alternate interior, exterior, or corresponding. There's midpoint, so you're going to have a definition of midpoint. And there's also another pair of things you can mark in there because it's a bow tie. The first two are pretty easy because they're both given. They've already got 2 of them, 5, 6. Okay, so I went ahead and I marked what was given. Now my third statement says LH is congruent to MH, so I'm going to mark that. How would I know those two things are congruent?
Because of the middle point.
Because of the definition of midpoint. Now the next one, remember I've got some parallel lines in there. So maybe I have some angles with parallel lines. It says angle G is congruent to angle J. How would I know that?
Alternate interior.
Alternate interior angles. Then number 5 says angle JHL is congruent to angle JHM. So they're both at H. They're in that bow tie, so those are vertical angles. That's how we would know that. Now, I have 2 angles and a side. So how can I prove those?
Angle, side.
Angle, side. Okay. We're done with the notes for today. We're gonna take a break from listening to me talk. I want you to get a Chromebook, go to iExcel,